Hi, this is Dr. Liu. This is the retracing lab. So to our left, this is the re box. We have a slit that can be adjusted. This is a single re slit because there's only one slit. We can also rotate it, and there's three slits. So now we have three re's and have something that's wide beam and also five re's. Okay. Another feature of the Reebox is you can pull the Reebox apart and push it in. So if I pull apart, just make sure the Reebox is a bit warm. So I'll just use my sleeves to push that back end. So if I push the Reebox, make it shorter, see that we can actually see there's diverging Re coming out of the Reebox because the Reebox itself has some optics inside. So if I pull the back end away, I can see the ray start to focus. Okay, yep, that's probably as far as I can do it. So what you want to do is you want to make sure it doesn't really um, focus or defocus, you see a parallel light ray. So how do you make sure? Well, the ray box, the slots are 1 centimeter apart. So all you have to do is to measure with a ruler somewhere further down. So if the rays are hitting say if you line up the bottom ray with 17 centimeters, and here's 5 ray, 18, 19, 20, 21 centimeters. Does it line up with 21 or not? Okay, mine lines up with 21.2. Apparently this is diverging. So I'll pull this back a little bit and that might be good now. So I'll look at my ruler, 17. Okay, so this is converging already. So I'll push it in a little. Mm, okay, so one, two. Okay, actually about 4 centimeters, 3 centimeters for the entire thing. So 3 centimeters, I'm going for that. This is roughly right. So roughly parallel light, maybe pull it back a little bit. Okay, so parallel light. I'm going to dim the overhead spotlight. As you can see, actually it's pretty well lit if you just dim the ambient light. Okay, so here's our system. And we can say we return to a single light ray. And here's a single light ray. If you push the slit down a little bit, that can close down some of that light leaking gap. So then we can look at the mirror. So in the dark, couldn't really see where the mirror is. Here it is. So here's a mirror. Okay, it starts reflecting light. I'll just turn up the ambient a little bit. Okay, see there's a mirror. So I rotate, right, the mirror reflects nicely. This is a flat mirror. We also have a curved mirror, so a spherical mirror in the 2D. So this is just a piece of pipe that was cut, steel, stainless steel pipe, I think. So this is the converging side. This is the diverging side. And we also have lenses. Lenses are harder to show because we need multiple rays, but we could use that, a prism. Okay, so we have a prism. There are some multiple reflections, but if you look over here, you can see the top here is a bit reddish. This bottom here is a little bluish. So that's what it is doing. It's dispersing the light ray, the white light into multiple color. Um, so that's that, a single ray. And we can also have this, for instance, so that comes in. We can't really see what's in between, but it comes out like this, right? So we can trace back, right? Okay, so let's get started with the lab activities. First, we need these converging and diverging lenses. So let's see, part one is have one ray and then uh, fall on the curved lens, so basically concave. You want a certain angle. So how do you record the angle? Say for instance, I'll just set it up like this. All right, I'll take out the pencil and start marking the um, the light rays by two spots, and then I will be able to draw the line. So let me pause the video. I'll grab a pencil. Okay, I've had my pencil here. So first I'll just I'll draw the light ray. So mark a spot, another spot. Make sure the paper isn't moving, and I'll put in the mirror. So hold down the mirror and draw its curvature. I drew the mirror's curvature. Find the far spot. Find the near spot. Okay, that's it. So I'll turn up the light, and so this is what I have. Um, I'll remove the rebox. So I have this, and I can line up the dots. Okay, so that's roughly where the reflects, and we are supposed to find a few things. For instance, to find the angle, incident and reflection, and also we need to find the curvature. So, okay, I have a protractor. Can't quite see. Okay, so my goal is to find the radius of curvature. So I have to try a few things. Um, hmm. Okay, so just bisected the angle. And let's see, how do I find the radius here? Well, I'll have to kind of go and assume where the center of the circle might be. So like over here, and get up to the curvature right here. The okay, so hold on to that. Uh, this is difficult to hold on. Okay, do I have the radius? Okay, I almost have the radius. This is a little less. So I just need to move back a little extra. Try to trace. Still a little less, but just a little. Okay, okay. Just a tidbit further away. Okay. I think now I can more or less trace the circle. Right, okay, so I'll mark the point right here. So this would give you the radius of curvature. I won't be measuring and telling you this, but you should be able to do this on your own. Just make sure you're drawing the diagram somewhere in the middle, so you have space to do that. and also measure the angles. And yeah, let's see. Don't have a protractor here, do we? Okay, we do. So this is, so it's a very rough angle measurement. That's probably okay. Yeah, I'll use a better protractor for sure. Okay, so that's for the concave surface. You also need to do the convex surface. So we'll bring this in again and make sure we mark the incident ray at 2 points that are far enough to draw an accurate line. Then we take, oh, the thing is standing still. It's stuck on the magnet on my computer. So as long as you dim the light, you can see the ray. The ray does get a little wide, but do your best to draw the middle. And draw the middle. Okay, I just drew the middle. And also holding on to the curvature so I can draw the radius of curvature out. Okay, I think I did good enough of a representation. Okay, here we go. So these are the two dots for the incident ray, and these are the two dots for the reflected ray. Okay, there's a little bit of discrepancy here because the reflected ray is wide, but that should be alright, it's expected. So again, we're trying to subdivide the angle, bisect the angle. So one really quick way is this. Don't know if you learned this from school or not, because this may not be taught at school anymore. So just do that, whatever length, okay? And go over here, go for the middle, go to this other side, also go for the middle. So there's a little cross, right? So last time I used just measuring distance. This time is actually angle bisecting. Um, at least from my 7th grader son, this may not have been taught at school anymore. Okay, so that's angle bisector. All right, and we're supposed to be doing some more measurements as well. And so that would be for um, single ray. So now let's move on to multiple rays. So we use the same surface right here, and we'll just grab a different piece of paper. There's plenty of paper. Grab a few sheets, and we'll use well, more rays are more accurate, and less rays means less work. So it's your choice. I'll go for 5 rays. I already have them lined up parallel. So let's move this back. And I'll do a concave surface first. I'll reduce the light a little bit, ambient light, so we can see the effect. Okay, wow, looks like it's focusing. Very nice, right? You should be turning this around just to see the effect. And then try to focus it more directly toward the center ray. Okay, so here it is. I wish I had some putty. Maybe I'll bring some putty so I can fix up um, the mirror or any other element. Okay, I think I managed to trace the mirror without moving it too much. So I'll trace the incident ray. Okay, so reflected ray go across that focus point, go relatively far, but not to the point that you cannot see the light anymore. And your pencil may also be blocking the light, so make sure that you know, okay, here's what you're doing. Okay, so reflected. So let's still do incident. Here's a reflected, incident, reflected, incident. Here's a reflected, another incident, another reflected, another incident. Okay, so we're done. Let's see. Move this out. So lots of little dots, right? The incidents are easier, so just go for parallel. Next parallel. This is the center ray, or you can always use different color dots for incident and the reflected. Maybe a red dot for the incident, and maybe black dots for reflected. Okay, so how do we do this again? Well, this is one of the reflect on the bottom, and it should pair up with the reflect on the top. So 1, 2, 3, 4. So that's the top. This is the bottom. Yeah, it's probably best if I have different colors, right? Very nice. You see that? It's just very nice. And this will be the second one on the bottom, second one from the top. These two pair up. See how nice that extends back to exactly where the incidence is ending. So here's one above, goes with one below. Oh, this one was off a little bit. And the one on the top goes with the one at the bottom. Oh, very nice. See that? This is what I'm looking for. Very nice, right? So then we can make some measurements. The focal length, so how far that is to the surface, compare that to the radius of the surface. I believe we measured that at the beginning already, so that's done. And okay, then the next one would be to use the uh, convex side. So let's turn the lights down. The convex side is a little harder because all the rays are wider. So also we need to make sure there's enough space on the right side to draw these lines extended backwards. So I'm just making sure the center reflected ray is going as planned. So if this doesn't really come out nicely, rotate this upside down, and if it still doesn't come out nicely, well, put your finger on top of the lens and it can tilt it down a little. See that? See that? Okay. Yeah, I do get shorter rays, but I do get to see where the center line is, right? Center reflection is. Make sure the center reflection lines up with the incident like that. So that's where this thing lines up. All right. Grab my pencil. Okay, I got a curvature. Slowly letting go so I'm not moving the spots. And again, the rays are wide, so pick the midpoint. These are all the incidents I'm trying to mark up. left side of the incident and the right side of the incidents. And reflected, I need two spots. I have the top one already, the second one also. The third one is overlapping with the incident center line. So the fourth one is a little difficult because I don't really get to see very far. The fifth line is good. I can see relatively far away. Okay, so we have all these dots here. I'll just be doing this again, getting the incident light first. Top, secondary from the top, secondary. I think I drew it slightly off. Below secondary, bottom ray. Okay, so let's do the first reflected. This against that very far dot. Remember the rays are wide as we reflect. Oh well, nicely done. And the second reflected ray is this. And I'm going to extend backward. I forgot to do that for the first ray. So let's do extend backward. And the third ray is just reflecting right back. So I'll just extend this ray backward. And the fourth ray are these two dots because I couldn't see far enough into that direction because it was just very dim. Extend far back. See this is not very consistent with the rest of them because I only could see that far. This is the last ray. See how nicely the last ray focuses around the rest, and this ray on the other hand does not do too well because I was only able to mark these two dots. If this part of the ray was visible, I would be able to mark further away to get my lines a little better. So I'll ignore that. I'll just say this is where the focal point is. I can measure the distance, for instance, right? So these should be dashed lines because they're not actual lines. So that's not too bad. We'll just go around with a round of erasers. Now I have dashed lines. Okay, so that's for multiple rays for these reflective surfaces, and we are down to multiple rays on lenses. So let's grab another sheet of paper. I really like drawing these. It's fun. Okay, so here's our ray again. We'll take a lens, and each group only has one of each lens. So you either do the converging or the diverging, and your left partner will do the other one. So here's a converging lens. As you can see, you need some space in order to get to that part. If you put this in the middle, then this gets really close to the edge of the paper. So not good, right? So bring this a little bit further to the left, and then let's mark the rays. I'll press this side down. I can see some more of that incident light. As I said, you don't have to mark. You don't have to use the 5 box. You can use the 3 box, but it has to be multiple rays. And behind the lens, 1, 2, 3, 4, 5. And you can even mark over here beyond the focal point. I would prefer that. The further you can mark, the more accurate the line becomes. Think about why. And now it's time to gently hold down the lens. Get the curvature one side. Oh, the other side is going to be difficult. I'll switch hands. I think I've been sitting too long. My smartwatch is letting me know I should be moving. Okay, there we go. So move that away. Okay, it's already max light brightness. Okay, so that's a lens, and that also gives us a midpoint. So I'll just draw a ray here for midpoint, and then I'll connect all of the incident side. Okay, so now transmitted side, because I have the dots over here, I'm pretty confident with the accuracy of my drawing. So there we go. Next line. Third one. Fourth one. And the last one. Okay, didn't get to go through the last one, but that should be okay. So this is roughly where all the rays are crossing, and then I go ahead and measure it. From where? From this center. The lens is thick, but I can always draw somewhere halfway between, so I can start from this point to measure distance to the focal point. Let's see if there's any need for finding out the radius of curvature of the lens. Okay, with the compass centered along the center line, find the radius. Yes, radius of a circle which produces an arc matches the arc of the lens. Yes, we do need to do that. So let's magnets. Okay, let's find out. So this may be a little difficult because where do we actually find, right? So it's kind of an estimate, isn't it? So I'll try. Okay, here. Okay, definitely not. Right, I'll go further out, and that makes it harder. Almost. Can I even do that with? Oh, okay. Tricky to hold that, but see how that goes really nicely. Yep, really nicely. So now you know exactly where the focal point is. All right. Difficult to hold the compasses like that, but I think we're good. So this is for the converging, and then do the diverging. The diverging is a slightly different story because the rays are diverging. Okay, so here it is, right? So again, you don't want to put this too far this way because what if these rays they do not cross on your paper, right? So you want to maybe move that a bit further to the right for the converging, a bit to the left, but you still want to leave enough space to draw the incident rays. That is a um, good distance for accuracy. Okay, so I must dim the light in order to see. Okay, okay, I moved my lens a little bit, but I was only doing the incident, so that should be okay. Okay, I think I moved my paper a little, relining up with the incident rays, getting lens curvatures back to the other side of the curvature. Now draw the refracted ray, holding the lens down. Draw as far as I can. Okay, we're good. Kind of finishing up the drawing of the lens, roughly cut in half. And now I need to finish the incident side. This all these drawings require some patience. Make sure you don't rush through this. Okay, so the incident side is done. Now the transmitted side. And also go ahead and extend backwards. Okay, my ruler wasn't really held far back enough. Okay, I think I barely had this lens far enough. I should move it a little further to the right, but I think I've lucked out. Keeping it a bit further toward the center will be better. We'll see. Extend all the way back. This really doesn't really need extending. That's already the incident. Mm, okay, so it looks like it's right here, maybe a millimeter beyond the edge of the paper. So what I'll do is, well, maybe I should have moved this to the right a little bit, but that looks all right. I can start measuring and give it a maybe a couple of millimeters to the left with how far the focal point is. This should be good. So see, this one here needs to be toward the left because we have distance over here. The other one here should be toward the right so that we have distance to extend the rays backwards. It's nice to have them as dashed lines instead of solid lines. You can erase some of that with a precision eraser like this, right? So that makes them look better. Okay, yeah, that's good. Okay, so there's more, and we have a glass plate, and we also have a prism. So the glass plate has a requirement of three separate incident and reflected angles, which means oh we better hold the glass in place, right? So it's best if we just draw the uh, the glass here, and then we can always line it back up in case we lose alignment. And make sure you have the correct sides because this side is the clear side and this side is frosted side, so make sure you use the clear side, and that's easy to line up, right? And also we can pick a an incident point and maybe just draw across. Looks normal enough. Okay, so we'll just line this up, and we need three incident angles, three refracted angle or reflected angles. Um, we'll switch back to single ray, and this time we're going to keep the paper in place and have different incident angles. Okay, here we go. Right. So, or maybe just rotate both. So have the incident ray hit the end of the your normal line right here. Um, if it's not, make some adjustment. Okay, so here it is hitting the end. All right, so mark this. This is one, and mark how the ray comes out. I have to dim the light to show the ray does come out, and it's pretty dim. So this side you mark two spots for the ray that comes out. Okay, so that is this is one, one. So I mark the ray that comes out, and then I'll change the angle. I need three incident angles. So here's one angle, and I'll rotate, and here's a second angle. Line up the ray, tip the ray to the where the black line, the line I drew. So I'll draw another spot, call this 2, and the transmitted ray also too dim to see with plenty of ambient light. This is 2. I'm just marking 2, 2. Okay, so here as you can see the 2. The other marking is certainly a bit beyond the screen, and then I'll draw. Okay, you can draw a third incident angle. This is slightly sharper. Okay, and I can mark that incident angle. This is 3. Mm, I do not really see the okay reflecting the transmitted because I think it's hitting the side edges. So I'll decrease the angle or maybe move the ray a bit, but I'll just decrease the angle. Okay, I decrease the incident angle a little bit. Okay, I decrease the incident angle a little. I'm still hitting the edge, close to the edge. This time I did not. Okay, good. So I'll mark this as 3, cross the other one, and here's a 3, 3. Okay, so a slightly better way is to just to push that over, slide it, parallel, so we don't hit the edge, and then we can actually do a slightly bigger angle, the so-called 3 prime that I crossed out. I'll reinstitute that 3 prime. I'll call it 3 prime, and here we get the 3 prime, 3 prime. Make sure the paper is flat enough. Okay, so let's turn the light back on. All right. So maybe for you, the best way is to not to line find the middle and actually defines over here because light ray comes in, it's going to hit the side, even with refraction. So it hits the side, it doesn't come out the bottom. So move this line down. Have your line probably drawn from here, which is better. Mine's already done, so I can't move it. But have your line starting from maybe the lower one quarter of this whole length. So now I have the dots, I can connect them. This is my first angle. I can measure it with a protractor. My second angle, I can measure that with a protractor. Yeah, third angle is a large one. I'm looking for the large one. So large angle. And how do I do the rest? Well, I moved my prism or glass block further down this way, so I extended. So for the first, I have these two dots. I link the dots. Okay, and I'll draw a normal line. Actually, I probably don't really need that normal line. I just need this line here. And I just need where the line hits, and I'll just connect that to my point of incident. So this is theta 1, and this is theta 2, slightly smaller. And let's do, well, yeah, theta 2, 1, 2, 3. How about A, B, C, C prime? Okay. So inside is 1, inside is 2, outside is 1. So A, B, C, and C primes. Okay. And for B, these two rays, these 2 points, I just needed this point right here. With this point, I can connect back to the point of incident. So this is A theta 2B, and theta 2C is this steeper angle. I know I shifted my glass block, so it basically comes back to this point. That's still within the glass block. I shifted it back up. So from this point, draw the line. So this is the angle theta 2C. So to test Snell's law, we need to measure these angles and do a calculation. And the last part is to see the um, light ray dispersion from a prism. So you kind of set it up this way. Okay, just kind of set it up this way, and it's for observation only. You can certainly draw the light rays. It's difficult to see this on the video camera, especially when it's dark. But in actuality, you should be able to see some of the redness on the top and the blueness on the bottom, and then that tells you the red has less index refraction, gets bent less, blue gets bent slightly more, but it's all very gentle.